Welcome to the AddMorePower Project. Today we will be talking to Peter.
My name is Peter Imrich. I'm the group lead of Material Science and Simulation at KAI. And KAI is the Competence Center of Automotive and Industrial Electronics. So we are an industrial research center, 100% subsidiary of Infineon. And we're dealing a lot with research questions in various fields. So we have many groups and many academic and industrial partners that we're dealing with on a national level and also on an international level. And within KAI we have, for example, groups that deal with reliability test development. We have groups that deal with corrosion, software development, machine learning and so on, as well as the group of material science and simulation. And within the material science and simulation group, we're dealing a lot with understanding mechanisms of fatigue of metallizations, for example, and developing new characterization techniques.
What is your role in this project?
KAI is involved in every work package within the AddMorePower project. So we're dealing a lot then also with the coordination and so on between many things, and we are more or less the bridge between Infineon, so the big industrial partner, and the other industrial and academic partners. So we have the topics that we would like to tackle and understand better at Infineon, and we at KAI try to develop new techniques and use our academic network and use then our consortial partners within the AddMorePower project to really get to the bottom of the problems that we have and try to develop new characterization and modeling techniques for that.
How would you describe this project?
The AddMorePower project deals with finding new characterization and modeling techniques for future semiconductor technologies. So, for example, gallium nitride and silicon carbide are new materials that are used within the semiconductor industry, and they have a lot of very, very good properties. However, they still have many more defects than silicon, for example. And we would like to understand better on how to characterize these defects and how to understand these defects in a way that would make us enable to characterize them in a way that we have a fast feedback loop for our development, so that we can in the future make these semiconductors better and better in a faster way. On the other hand, also there's the topic of metallization fatigue. So for example, metallizations are used in power semiconductor and are very important, as well as the interconnect materials, which are also made out of metallizations. And all of these materials are packaged now in more and more complicated ways, and the properties that they have to have are more and more complicated. So in the future, the reliability requirements are getting higher and higher, and therefore we have to find new ways of understanding and characterizing them, as well as modeling them so that we can make sure that they endure the whole lifetime of the application.
What are you looking forward to in this project?
So I'm very much looking forward to collaborating with all those experts on a national and international level within Europe. Since all of these experts are really good in their field and they have characterization and modeling techniques that we haven't used so far, and so we can really dig down and get some answers to the questions that we have and use our samples and their knowledge to gain much more for the future to come and understand our processes and enable even more reliable and better working semiconductor products in the future.
Thank you. If you want to know more about the AddMorePower project, head over to the website addmorepower.eu.